theory. Warner limitation so today is not possible, but till Warner theory I will discuss today. Okay. So what happen fluorescent ligands? Okay, in this you can observe if I will write here C2 C2 CO3 2 negative like this compound if you will observe. Okay, SO4 2 negative sulfate. This type of ligands, no, sometimes for different coordination compound they will show more than one density. Okay, D1 value also two also. Max. You can see CO3 2 negative. It can show the density one also two also in coordination compound. Okay, but it depends on coordination compound. Okay, so that is a fluorescent ligands. You can say key which so flexibility flexibility in density. Okay, and I will give you some example as SO4 2 negative. Okay, NO3 negative, NO2, O2. So this type of example is there. Okay, it depends on coordination compound. Okay, sometimes they will show you one. Yeah, sometimes they will show you only two also. I will write one example here also. So you will get more idea. I have cobalt 3. I am taking example of SO4. Okay, 2 negative. Cobalt 3 positive I have. In this compound, ammonia is there. They are saying the electron as a coordinate. Okay. 5 ammonia is there here. 3 I am drawing. 4 and 5. Okay. So in this compound, I am writing first formula, then you will understand more. CO ammonia 3 5 times and SO4 Cl. So in this case, you can see here sulfate. I will show here. One person also come today. Oh, Kusi. Okay, what happened here? I will making a diagram. See here. In this case, sulfate will giving only this electron. Sulfate giving now only this electron here. This electron will not participate in the coordination compound. Okay, in this case. Okay, guys. So that is why I'm saying ki here sulfate giving only one electron. In this case only. Okay, in this case, sulfate will giving only one coordination bond in this compound. Okay, but I will give you also one more example. In that you can observe sulfate giving. Good evening. Sulfate is giving two electron also, two coordination models. I will give more example. If I will write this formula, cobalt NH3 4 SO4, okay, Cl. So in this case you can observe now sulfate will giving two coordination bond with cobalt in this case. Okay, in this case sulfate will giving you two coordination bond with cobalt. So it depends on formula. Key sulfate will giving you one density one value or two. Okay, that will be called flexibility. Okay. Now I'm starting now, Prajwal. Now I'm starting Prajwal now. Flexibility ligands. I start. Okay. So in this formula, you can see sulfur is giving here one only electron. But in this formula, you can observe here now sulfate will give you two electrons in this case. Why? Because now I have only 4 ammonia. So that is why now sulfate will give both our coordination electron they will give to cobalt so that they can make coordination number 6. So that is why in this case two densities 2 is there. Okay, in this case of sulfate, and in this case density of 1 for sulfate. Okay, guys, it is clear. I will move ahead. Okay, Tajik, what happened? Tell me. So, Tajik, these are na example. Okay, they will show the density where more than one also. It depends on coordination compound. Sometimes they'll show one here, sometimes they'll show also two. Okay, it depends on coordination compound. Okay, so you can see here, sulfate are giving here in this formula one denticity, but in this formula they are giving denticity two. So that is a case here. Okay, okay, here you can say sulfate are flexible here, and it depends on coordination compound. Okay, so that is why we call plexidended ligands here. Okay, okay, now Prajwal is okay. Sorry, Tejas is okay. Okay, guys. Okay, now you know one more. Just I will give one more two definition only. Then we'll move on IPC name. Okay, this definition I am just giving is not so much easy, but in the future they will help you. Okay, breathing ligands. You know what is the meaning of this? Ki one lone pair. Okay, if one lone pair giving their one ligands, they will share the two lone pair to different metal at a one time. So we call this a breathing ligands. Okay, interaction of breathing ligands with metal ions, yeah, atoms. Okay, you can they also represent like this. Okay, sometimes one legend will share their lone pair with two metals. So that is a breathing ligands. Okay, like that. OH negative. So what happen here? In this case, na, ki oxygen also have lone pair. Oxygen has a negative charge also. So in this case, sometimes OH will share at a one time two ligands two coordinate compound. Okay, with metal. Okay, that is a breathing ligands. Okay, and sometimes carbonyl also can also share two coordinate compound with two different metals. Okay, yeah, same metal but two different metals. Okay, that is a breathing ligands only. Okay, this is a definition. Okay, this is not used so much. Okay, now I'm moving ahead. Okay, now one ligands is famous. You very experienced with that. Organic ligands. You know organic ligands. You know in organic ligands, if you observe in the organic ligands, their IPC naming, they will write whatever organic compound IPC naming is there, right? They will write only exact name. Okay, here they will not add any suffix. Okay, they will not add here any suffix. Okay, in the organic ligands like that. Key sub C. Suppose that if you have methane, okay, so methane can never be happen ligands. But if you take one hydrogen from methane, so it become CS3. Now, okay, now it's become methyl group. So now you can take the electron as a covalent bond in this case. So if I will use CS3 negative in the coordination compound, so I can use as a IPC naming without any suffix. Okay, here. Okay, guys, that is a organic ligands. Okay, no suffix will be added in the name of organic ligands. Okay, phenyl, if I will using here, C6H5 negative phenyl. So if you see any phenyl group in the coordination compound, they will write only phenyl. They will not add anything. Okay, okay, guys, organic ligands is clear. Okay, I will share the notes. So you can also see this is the only definition part. Okay. Now, guys, we will move very now. Your main organic, main your coordination compound will start now. Okay, now onwards. Till now, it is the definition part. Now, please observe very good. Okay, see, guys, these breathing ligands. What happened? Breathing ligands. You see what happened? Na? Sometimes you have OH, O negative H. You have yes, you have sometimes carbonyl group. Sometimes they will share their they will make the covalent bond with two different at a one time they will share their lone pair negative charge with two different metals. Okay, at a time. That is why we call breathing met. A, what is happening here? Why you written A? What happened? Why you writing A? Nothing, sir. Okay. So sometimes like carbonyl also will share their electron in some compounds. Okay, I'm not saying every time. So that is why we call breaching. Okay, and sorry, I am not understanding. Okay, that is a breaching ligands. Okay, now we're switching very important topic. See, your chapter, this coordination compound, this your coordination compound will vary depends on D and M block elements. Okay, if you observe, normally your D elements, second period, third period of D block, you can see their elements are participating here. Normally in the metal, you can observe. Okay, so that is why their oxidation state play very good role here in the coordination compound. Okay, I will write some coordination number. So please is very needful. Okay, please observe. Okay, okay, guys, it will help you to understanding the coordination compound in the future. Okay, I know you guys remember, but just I'm writing. Okay, for knowledge purpose only. Okay, for third period D block elements, for the center metal ion, their ions are two types normally. Plus two, yeah, plus three in a coordination compound. I'm saying. Okay, if you see 3D third period of the element, third period of the element of D block, you can observe the center metal ion in coordination component have two types of coordination number generally. Their oxidation state two types. Okay, plus two, yeah, plus three. Okay, if you observe in a coordination compound, if your third period of an element they have plus two oxidation state, so in this case, your coordination number will be four. And you can observe where center metal oxidation state is 3, you can observe their coordination number is 6. So generally it will happen. So this thing will help you in future, okay, to making the coordination compound very fast, yeah, to understanding. Okay, so please remember this. Okay, okay, guys, some are very famous. I will write here for silver and gold. Okay, their oxidation state two types, plus one, plus three. For three, coordination number is 4. 4 plus 1 is coordination number is 2. Coordination number is 2. Don't worry. This all list I will share with you. Okay, don't worry after class. So don't worry. I will share full list of D block elements who will show the multiple oxidation state with coordination number. So don't worry about that. Okay, guys. But I'm just giving main example here. Okay. And platinum and palladium. Please remember this. This is a very important. Here people will forget. They will show you plus two, only two oxidation plus 2 plus 4. If you see plus 2 oxidation, for that coordination number is 4 and plus 4 coordination number will be 6. Coordination number will be 6 for that. Okay. Okay. And I will see also one thing more here. Key for iron and manganese and copper, you can observe if there are plus 2 oxidation stages will be there. For that coordination number is 4 also possible, 6 also possible. So please do not confuse in that. And one thing I also mention here is very important. Generally I'm saying, okay, this thing I will tell you when I'm telling the IPC naming, when I will discuss with you or coordination command, then I will show you how these things are related. Okay, generally lower oxidation state, lower oxidation state show you lower coordination number. Please remember this. Generally, your lower oxidation state show you lower coordination number, and higher oxidation state will show you higher coordination number. Okay, please remember this thing. Okay, so you can see here for CMAP, if you have oxidation number 2, they'll show you 4. If you have oxidation number plus 3, they'll show you plus coordination number 6. Okay, for third period element, you can observe. So that is I'm written here. Generally, you will observe in coordination compound, lower oxidation state will show you lower coordination number, higher oxidation state will show you higher coordination number. Okay, now I will start some. Okay, so you will get the idea. Okay, guys, today I will write some example of coordination compound. Please try to so. Okay, I will help you also. Okay, now what happened? Now we find the coordination number and oxidation state also for coordination compound. Okay, I'm writing here. First example is K4, Fe, Cn, 6. Okay. For that, you have to find oxidation state and coordination number. Okay. Okay, guys. So, uh, I know you guys have very good experience here. So I'm just giving the idea how can you calculate. Okay, then you can also try by yourself also. Okay. See, I have to find first oxidation state of iron only here. Okay, because it will show you multiple oxidation state in the complex ion. So that is why I have to find the oxidation state of iron here. Okay, so how can I find here? See, how can I find here? See, I can write. See, potassium will show always plus one. So 4 into 1, I can write 4. Okay, for X, I will assume for iron. And cyanide will show you minus 1 ion. Cyanide will show minus 1 ion. So that is why I will write here 6 into 1. Okay, because 6 Cn is there. That is why. And overall charge is 0 on the coordination compound. So I can get here 2 plus 2 here. 6 Cn is there. Okay, so that coordination number 6 also there. So that is a oxidation state is of iron is plus 2. But how to find the coordination number? For coordination number is a one idea is here. I will write here. Coordination number is ligands of 1 into their density 1 plus ligands into ligands second and density 2 also. Like that. You have to find the coordination number like that. So in this case, how can you find coordination number? So you can see here. Here you can observe here. You have only one. You can see here only one ligand is there. Only Cn. Okay, one is there, and dentist. Sorry, 6 Cn is there, and for per cyanide, what is the density value for cyanide? Minus one, but coordination number you take one only. So density value for cyanide is one, and here cyanide is 6. So your how much coordination number coming here? 6. Okay, so for this compound, how can you find oxidation state and coordination number like this? Okay, I will give you more one good example. Please try to find. Okay, Nikhil En2 Cl2. Can you find for this? Can you find for this oxidation state? And today you have to solve the question with me also, guys. Okay, I am not only one person who will solve the question. You guys also have to come with me. Okay, you have to also solve the question today. Okay, please try to find here oxidation state and coordination number both. Okay, because now I am taking online class. If you will not learn how to calculate, so it is difficult for you. Okay. Yeah, I know plus 2 plus 6 is plus 2 or 6 is here. Okay. See how do we calculate? Here we write x. See, what is the meaning of En here? Is a ethylene diamine. Okay. Is a ethylene diamine. But ethylene diamine have no uh what happened? Tetrahedral? Okay, I'm not telling now shape of that. Okay. Because see here. I'm taking a see diethylene amine is there. Okay. Diethylene diamine is there. Okay. On this, no ion is 0. That is why I'm taking 0. For chlorine, minus 2 charge is there and overall charge is 0. So now you will get here plus 2. Okay, so here plus 2 charge will come on the nickel. Oxidation state you can. Okay, I know diethylene amine 2 is there, and for per one ethylene diamine you have density value is 2. For that D value is 2. So that is like 2 into 2 plus chlorine, no, only 1 is there density value. So how much come here? 4 plus 2, how much? 6 will come. So here coordination number 6 will come. Okay. I will write here more one. PD, ED, TA. Okay. In this case, you can find. Oxidation state and coordination number. Please tell me in this case. Guys, please tell me one thing. All you guys are clear how to find oxidation state and coordination number here? No, no. In this case, coordination number 6 is there, and oxidation state 4 is there as well. Okay. See, guys, one thing I mentioned here, key for platinum, their oxidation state plus 2 is there, yeah, plus 4 is there. Okay. And you can see plus 4 plus 2, you have coordination 4, yeah, coordination number 6. Okay, you can observe here. So that is why I'm writing here. See, if I'm see, you have no for EDTA value, 3 is also there and minus 4 is also there. But in that you have one problem is there. For minus 3 ion charge, you have d value 5. For minus 5, minus 4 value, you have the density value 6. So, platinum have only two type of valency, plus 2 or plus 4. For plus 2 plus 4, they can make 4 or 6 only. So here 5 is not possible. So that is why here only one option is remaining, 6 here. So that is why you can observe here ki here additive charge is minus 4. Okay. Okay. You can here also take like this x, okay, minus 4 into 0 is come plus 4. So here palladium have plus 4 charge and coordination of number will come 6 because EDTA have, you can say like that ki ED have 6 number of density into 1. That is a coordination number. It's coming 6. Okay. So that is I'm saying ki your oxidation state will help you to find the piece. EDTA 3 negative you're saying na? Okay, 1 second. See, EDTA, you are writing some message? I'm drawing here. See, EDTA 3 negative. Okay, see what happened. Ethylene. First you have see ethylene. What is the name here? Ethylene. Okay, diamine. Okay, diamine. Here I am using a 3 negative charge. So that is why here tri acetato will come. Okay. Okay, what is the meaning of that? First you make here one ethylene group. Okay, CH2, CH2. On that both corner you have two nitrogen group. Diamine. Okay. Then you have triacetato. So that means CH2 COO negative. And also here CH2 CO negative. Here also CH2 CO negative. Here only H will come. So that is a C you will see here 1, 2, 3, 4, 5. So that is why here density value is 5. Okay, okay guys. It is clear. EDTA 3. EDTA 3 is clear guys. Okay. If you want to ask EDTA 4, so in EDTA 4, in case just replace here H and put here acetato 1 group. Okay, so it become 4 negative. Okay, like that only. Okay, guys. So in EDTA 4, you have density value 6 because now you have 5 already you have. Now you add here 6. If you are adding replacing H, it become now density value 6 here. Okay. Okay, why I'm discussing oxidation state number now? See, guys. Okay, just give just for me, just calculate some coordination number, guys, please. Okay, I will writing here. CO ammonia 2 OX EN CN. Guys, please remember this. When I'm sharing the notes, in the notes, you have 10 to 20 questions are there. okay, for oxidation state. So please try by yourself, okay, try by yourself, okay, in your home, okay, oxidation state and coordination number. But whatever the tough is there, I will discuss here, okay, and different types, okay. So in this case, please tell me oxidation state and coordination number. So now you have to find coordination number here, X, okay, for Kobler. Okay, for ammonia there is no charge. Okay, and oxalate have two negative ion, -2 ion is there. So -2, and for diethyl no charge is there. Okay, but for chlorine -1 charge will come, 0. So it's come +3. So here oxidation state for chloride is +3. Now you have to find coordination number. Okay, see what happened here. For ammonia is 2, but ammonia will share only one coordination bond, that is why come 1. Density is coming for ammonia is 1, plus oxalate. Oxalate can be share two covalent bond at a one time, so that is why their density is 2 into 1, plus En also can share 2, density value 2 for En, that is 2 into 1, so it's become how much, +6. So oxidation state is +3 and coordination number is 6 here, okay, in this compound. It is clear, guys, for everyone? Okay, for me just try this, guys, this, okay. Fe NO2 die in AC +1 here. Please try for me coordination number and oxidation state both. AC acetyl acetate. Acetyl acetate is there na? AC is a -1. Acetyl acetate. That is a acetyl acetate. Here what happened? Because of Arrhenius, they will share the electron here from here, both oxygen. So that is why it's become AC -1. AC -1. Because of resonance, here structure will change here like that. Okay. So now can they will they share as a like that. Okay. So that is why we write AC -1. Okay. This is a shortcut form. Okay. So in the question, how to find +3 is a what coordination number is coming? +2. Here +1 you include. If you include +1, I think so +3 answer will come. Try here. X for iron. For NO2 -1 will come. Okay. For diethylene, that is 0 will come. For AC -1 will come. Here outside +1 charge is here. So now just see here X value will come +3. Okay. And coordination number how to find? For NO2 1 is there. For diene how much? Coordination number 3. For diene value is 3. Okay. Diene they have density value 3. Okay. Plus for AC 2. I also here also they will also 2 coordination number here. Okay, so how much? 3 to 5 plus 1 plus 6. That is a coordination number +6 here. Okay. Guys, one thing I also forget. Uh, for some ligands, I will say Again, diagrams and their diagrams I separate. I will share again. Okay, today night because I make edit the notes again after you told na you will not understand proper way diagram. So that is why I modify the diagram also again. So after my class, please revise once more. Okay, ligands. Okay, okay. Now it is clear. Okay, guys. Uh, Charan, why are you putting positive sign here? No, no, no. I'm not putting this. Only question is the question, Harshit. I'm not putting from my side. Just I'm putting for question only. Solving the coordination number on oxidation state. I'm not putting plus one. Okay, it's only for question purpose only. Okay, it's not about concept. Okay. For CN coordination number, you put plus six. Where? Where? Here, guys. What you are saying here?